Thank you. Today, I'm very honored to interview one of the giant in intravascular imaging, Professor Gary Mintz. So without further delay, let me start some of the interview questions, Professor Mintz. So may I ask what initially sparked your interest in cardiology, especially in the area of intravascular imaging?
So that's really two questions.
Right.
When I was a medical student, the cardiology department was unusually strong. And I had the opportunity between the first and the second year to spend 12 weeks in the cath lab, working with the 3 attending invasive cardiologists and the 3 cardiology fellows. And I was able to see almost every interesting cardiology patient in the hospital. So that was in the early 1970s, before interventional cardiology. Then as my interest in cardiology grew and I took a cardiology fellowship, I had 2 main focuses, and that's primarily what was available at the time. I first started doing 2D echo in March of 1977 when I was a first-year cardiology fellow. And when I finished my fellowship, I had a dual appointment in the echo lab and in the cath lab. Again, this is before interventional cardiology. Once PCI became available, I started doing PCI, and then my dual interests were clinical echocardiography, and I ran the echo lab, as well as interventional cardiology, and I was a busy interventionalist. It was a natural marriage of those 2 areas of interest when I joined the Cardiovascular Research Foundation in 1991. And I was simply asked to take over the intravascular imaging program because I had both the imaging background and the background as an interventional cardiologist and could speak the language of the interventional cardiologist, as well as understand the very early and quite frankly awful images that were available at the time.
Well, I think make perfect sense. That is as you said, there's a perfect marriage between the 2 expertise that you already have. Second question is, how do you envision the trajectory of intravascular imaging in the coming decade?
So I see an improvement in technology. For a long time, imaging technology had lain dormant. The images were no better. The systems were no better. Quite frankly, people got frustrated and tired. But there's been a recent burst in engineering creativity with many new companies and many new approaches, and the quality of the images has only gotten better. The ease of use of the equipment has gotten better. The catheters are still a bit of a problem, but they have improved somewhat. And so I look forward to the next 5 to 10 years where the quality of the images, the quality of the equipment will only improve, and so become much more attractive to the interventional cardiologist.
Thank you. So what kind of, you mentioned about the quality that would improve. Is there any potential advancement in terms of the design or the catheter-based things that you anticipate that would broaden its application? If you need to name 1 or 2 in particular, what particular area you think that would make a big leap?
Well, certainly in the IVUS world, the advances of high definition, high frequency IVUS have been extraordinary. And it's clear that transducer frequency can increase, but there are trade-offs. What I have observed is that trade-offs are encourage the engineers to find solutions. So I expect the IVUS images to get better. The OCT images, again, were pretty stagnant for a while, But now we see deep OCT, which manages to increase the penetration in ways that I never thought would be possible. And of course, everybody talks about hybrid imaging. It is no longer a fantasy. The catheters are no bigger than the standard IVUS or OCT catheters. The images are as good as either, and then when combined are even better. And there are incorporation of tissue characterization. So I see all of these advances happening over the next decades.
Oh, fantastic. I think that that's a lot of new information. When you talk about IFRS, is mainly for the coronary intervention or structural heart intervention?
Well, that's a really interesting question. So I have started to do some work with some junior colleagues in Europe about using intravascular imaging in structural heart intervention. Obviously, there is some ICE work that's been done, and some interventionalists use TEE to guide structural procedures, but there is the opportunity to create unique catheter-based imaging technologies that can not only image the structure of the valve, both the native valve and the intervention to the valve, whether it's implantation or repair, as well as detect things such as complications, paravalvular leaks, and so on. But that's at the beginning. I think it's a huge possibility. Whether it will pan out or not, obviously, time will tell.
Sure. Could you share with us what is your current research focus?
I don't think there's one research focus. We continue to explore imaging guidance of PCI procedures. We continue to understand how devices work and how they don't work. You know, for example, the modern second and newer generation drug-eluting stents are while they're easier to deliver, they clearly don't have the radial strength. And we have recently begun to observe that they are associated with chronic recoil that we never saw with first generation DES, and it may require the engineers to rethink their designs. Obviously, drug-coated balloons are the next wave. Nobody really knows what the imaging findings are. There have been some very early papers that haven't really told us much, but that's going to be a huge opportunity to look at drug-coated balloon interventions, follow them over time, and understand the mechanisms of success and failure, quite frankly, just like we did in the early days of PCI with plain old balloon angioplasty and atherectomy.
Yeah. I'll just give you a bit of background. I'm a cardiac surgeon, so I'm actually very interested to know the finding you just mentioned, the sort of a recoil, chronic recoil that could constitute, you know, the maybe intermediate or long-term failure of the drug-eluting stent. Yeah.
I mean,
Yeah.
I wrote papers both in bare metal stent days and first generation DS stents saying and documenting that recoil was rare except in isolated instances. It's no longer rare. And that's because the stents have been designed for deliverability, flexibility, and have given only second consideration to strength.
Now, over the years, you and your team have achieved a remarkable breakthrough in intravascular imaging. Could you share with us some insight, what kind of barrier that you have faced and challenges you encounter during your research journey, and how do you successfully navigate it through all these hurdles?
Yeah, the biggest hurdle was getting the papers published. I would get reviews that essentially would say, you cannot do what you say you are doing. You cannot do this, you cannot image that, you cannot make these measurements. And even though we had set the foundation by publishing histologic comparison and validation. So my solution was, quite frankly, very simple. I got angry. And I got angry with the editors, and I wrote them letters saying that this is absurd. And I simply asked them one question. Do you want me to continue to send manuscripts to your journal, or should I look elsewhere? And they got back to me, and to their credit, they said, no, we have read your correspondence and we tend to agree with you. And from that point on, the articles got a fair hearing. But the beginning was tough. People simply were unwilling to accept the data from the intravascular imaging studies that we were publishing.
Can you share with us your record of being asked to review or rejected? What's your record?
Oh, I am. Well, so if you're asking about my record of submission and rejection, there has almost been no paper that has not been published. It may not be the
Very good.
first choice, but we always find a home for every paper. And unfortunately, some very, very good and, in retrospect, important papers never got the visibility and the credit that they deserved. And of course, this has been a 30-year journey. So if you look at talk to a junior cardiologist, or in your case, cardiac surgeon, as far as they're concerned, anything published more than 5 years ago never existed.
That's very true. And I mean, I really enjoy what you say is we need to just be persevere, you know, and keep on trying to find a home for the work that we have done. May I follow through my question with your contribution to intravascular imaging been widely recognized, no doubt. Could you please share with us which period of the research do you think is most significant and or the turning point of your entire research career?
It was
Can you
probably
name one?
the first 5 to 10 years. And that's when we started to use intravascular imaging to understand device success and failure, not only acutely, but long term. And we began to make observations as to why balloon angioplasty and atherectomy at that time had a high restenosis rate. And it totally contradicted what the pathologists suggested and what individuals doing biopsies suggested. For example, it was thought that restenosis after balloon angioplasty and atherectomy was primarily intimal hyperplasia or tissue growth. And the imaging studies showed the opposite. It was probably scar contraction from trauma to the vessel wall caused by the balloons or the atherectomy devices. And so I went to Japan in 1993 and set up a small study called the SURE study that it did intravascular imaging before and after intervention, 1 day later, 1 month later, and 6 months later in about 60 patients. And we critically studied the natural history of the interventional process. And that set the stage for almost everything that happened afterwards, whether it was progression and regression, whether it was studying stents, whether it is now, hopefully in the future, looking at drug-coated balloons, whether it's looking at bioresorbable scaffold, and so on. And the other important period was understanding why early stent implantation was such a disaster. And that was simply that the stents were never properly expanded or implanted, and they were sitting in the artery, almost floating in the lumen, and were therefore associated with a high rate of stent thrombosis.
I mean, that's two very insightful period. And I could appreciate the degree of attention to details that you like collaborate with it when you have your research done in Japan. That was back in 1993, I heard, right? 1993.
Correct. It was done at Kokura Memorial Hospital with Professors Nobuyoshi and Kimura.
All right. So do you think now there are a lot of new product that in the pipeline? Do you think such a degree of extensive follow-up from early, intermediate, or long term is required to study the phenomenon that you just mentioned?
Totally. So why did bioresorbable scaffolds fail? They failed because they did not have good long-term results.
Yeah.
And part of that was because they were being implanted incorrectly. Instead of saying, let's do studies using imaging guidance to understand proper implantation technique and modes of failure, the company, mostly Abbott, said, do not use imaging to implant the absorbed scaffold. And so there was no data. Nobody understood why the scaffolds were failing at a rate higher
Yeah.
than contemporary metallic drug-eluting stents. If you begin by imaging and you do careful follow-up, you will understand, or we as physicians will understand why devices work, why they fail, and if they fail, um, how to use them better. So it's in vivo pathology, it's in vivo natural history, and there's no other way other than intravascular imaging.
That's very thoughtful and insightful. I think our surgeons should do the similar thing to assess our graph as well. And
If I
so
can interject, I want to give some credit 50 years ago to your surgical colleagues. So in the early days of 2D echo, there was no database, there were no standards, there was no histopathologic correlation. And I was working at a hospital in Philadelphia. Every patient that went to surgery came to the echo lab first and then went to the OR, and we sent an artist to the operating room to sketch the findings, and your surgical colleagues were fundamental to our understanding 2D echo at that time.
well, thank you for your compliment. I'm sure a lot of pioneering surgeon they do really appreciate the collaboration. As for myself, I normally would invite my echocardiologists to accompany us when we're doing like mitral repair or any structural heart intervention. So that would actually add a lot of values to our growth in terms of the knowledge. Now, maybe I follow for another question. So, as a pioneer in the intravascular imaging, what advice would you offer to young aspiring scholar to make a impactful contribution like you to the field?
I have two general comments or general pieces of advice. The first is spend time in the cath lab not doing PCI procedures. You will learn, or the young interventionalists will learn so much about what is good and bad. They will get ideas from research, just from cases that are being done, whether they are done successfully or whether there are complications. And the ideas for the cath lab are what generates ideas for research. Anybody who thinks that research is just done in front of a computer or in a core laboratory misses the fact that these are clinical techniques and should be applied clinically. And that, of course, begins with the patient. And in our field, that means spending time in the cath lab and understanding and getting ideas for projects. The second piece of advice is to look at the images and learn the images. I am annoyed when a young scholar comes up to me and says that he will use the database generated by technicians in the core lab and just take the numbers and write papers. And I say, well, have you looked at the images? Oh, I don't have to. They look at it for me. If you don't understand the images, you do not understand coronary disease, you do not understand pathology, you do not understand how interventional cardiology works and how it fails. You must be able to analyze the images yourself, and then you'll get observations. You see things that you just never quite understood, and then that will also promote research ideas. So it begins with the images and the patients, not with numbers entered into a computer.
absolutely agree. I think as a surgeon, I know some surgeon who going to repair the mitral valve, they just look at the report, but I think it's, not very sensible. We should definitely look at the images by ourselves and try to understand the pathology firsthand. And well, for the younger scholar, when they face the hurdle, the setback that you have faced, for example, submitting publication or so, how would you advise them? Any advice? Yeah.
Right. They need a good mentor. Now, the mentor does not necessarily have to be an imaging expert, but the mentor has to be someone senior who has struggled with research and publications and can give them advice. They also have to be a little realistic. I have seen young scholars say, I'll submit this to the New England Journal of Medicine or Lancet. And of course, it's really not of that stature. And when it's rejected, they get depressed. They should not give up, and they should be realistic. I've always thought of the concept of momentum. If you submit a paper and it's rejected and you get depressed and you put it aside for a year, you will have forgotten the message, the issues. So, keep going until it's accepted. Don't, don't get too depressed. Don't ignore the paper. Just keep working on it. But finding a good mentor is always a really great idea.
Definitely. I think for a lot of young aspiring surgeon or cardiologists, we always found the biggest problem is how to have like a concrete and workable plan. And maybe that is the exact time where the senior or your mentor could give you advice whether the project is workable. And yeah. So how often do you rely on like sharing with peers at the time when you're young, of course, to share with your peers to see the plan is workable, or you just go directly to your mentors?
So when I was junior, there really
Years
were
ago.
there was really nobody else working in the field. My
Yes.
2D echo research was pretty much in a vacuum.
Yeah.
The early intravascular imaging work, not many people were doing what we were doing. But I was, at least with intravascular imaging, and granted, I wasn't junior then, I was already in my 40s. I had colleagues that I could discuss it. And I'll credit one in particular, Jeff Popma, who joined CRF about the same time that I did and now works for Medtronic. He ran the core laboratory, the angiographic core laboratory, and set up the first database. And we were very, very close colleagues, and we bounced ideas back and forth. Some of the things that I saw gave him ideas for his work. Some of the things that he saw gave me ideas for my work. But I will say that even today, I share ideas with colleagues, maybe even more so than when I was junior. And I collaborate with people in China, in the UK, in South America, in Korea, in Japan. And I find this international collaboration, both domestically and internationally, hugely helpful, particularly as the field gets more advanced.
Yeah, I absolutely agree. Hopefully one day your collaboration will extend to Hong Kong into my unit as well.
Well,
So
I've got very good friends and colleagues in Hong Kong, and I've
right,
been there several times.
sure. Really, thank you very much for today. I think we have done all the question. I actually extend a bit more, Alyssa, right? So thank you very much, Professor Mintz. Thank you.